Hello everyone. Today let's solve the problem number 51, n queens. So what the question states here, we need to place n queens on n into n chessboard, right? So we have to place n queens on a n into n chessboard such that no two queens should attack each other. So no two queens must attack each other. This we have to keep in mind. A queen can attack in three ways. One is same row. Two queens cannot be in the same row. Same columns. Two queens cannot be in the same column. Third one is same diagonal. Two queens cannot be placed diagonally. So these three things, these three conditions we need to keep in mind. Suppose let's consider this queen here. So another, we cannot have the queen in the same row, right? So that's what the first one says here. Also, if we consider column, we cannot have the queen here in the same column. So when we consider diagonal, left and right diagonal, so we cannot have the queen here. Also, we cannot place the queen here. So that's what they have given in the question, right? I hope the question is completely clear. So we need to place n queens on n into n chessboard such that no two queens attack each other. A queen can attack in three ways. We know one is same row, same column, same diagonal. Two queens cannot be in the same row. Two queens cannot be in the same column. Also, two queens cannot be placed diagonally. So I hope the question is completely clear. So what we need to do? We need to return all the valid board configurations. So we need to return all the valid board configurations at the end, right? So let's come to example 1 here. They have clearly shown here n equals 4. Then 4 into 4 board we have to check for, right? So then here the output they have given here as this one. They have clearly shown in the figure, right? So these are the two solutions we get, right? So there exist two distinct solutions to the 4 queens puzzle as shown above. You can clearly see here. So one queen cannot attack other queen, right? So these are the two possible solutions we get when n equals 4. Here the second example, this is same as first one, but n equals 1, we have to go decide this one. We have to go with 1 into 1, right? So the solution output will be q. So only one, right? So that's what they have given here. Let's discuss the approach first, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. First, let's discuss the approach. Let's consider the first example that they have given, right? So let's consider this example itself. So here, let's discuss the approach step by step. So first thing we have to keep in mind here is we are going with the backtracking, or we are going with the recursive backtracking, right? So this we have to keep in mind. So this is for when n equals 4. Then we have to consider 4 into 4 board, right? So this is important. We are considering, I have took the same example that they have mentioned in the question. First example, when n equals 4, 4 into 4 chessboard, right? So here initial board, here we don't have anything. So I'll just place the dots as they have given in the question, right? So just give me a second here. So yeah, this one. So here we don't have anything in this step. This is initial board. You can clearly see this is the initial board, right? So we don't have anything yet. So first step is we have to place the queen in the row, first row, this one. Let me come here. We are placing the first queen, right, at row 0. So I'll just come here. Let me give here place first queen. So why this is stopping actually? So just give me a second here. So we are placing the first queen. We have to place the first queen, right? So I'll just write here, place first queen here. And the row 0 here. This is fine. So we are placing here 0, 1. So all others will be mentioned with a dot in this case. So right, this is what first queen we are placing at 0, 1 or the first column here. So you can clearly see, right? This one column 0 will be X. In this one, column 1 we have placed the queen. This one will be again. So this is step 1. We have just placed the first queen, right? So let's move on with the step 2. Now we have Q here. This one, right? Now what we have to do? We have to place the second queen. So here, let me give place second queen in the row 1. So we have to place this one. We have the rule that we should not, so queen attacks diagonally. Here it is not possible. Here also it is not possible. Queen also attacks straight, right? So column. So we cannot have the queen in the same row, in the same column as well, right? This is also not possible. So we are placing the queen here in this case, right? So in this case, we are placing in the column 3. In the step 2, here we are placing queen. This is fine. This is step 2. Let's move on with the step 3. So we have to place the third queen. So we have to place the third queen. Nothing but row 3. So here first we had queen here. Sorry. We had queen here, had queen here. So this one, let me represent this one with a dot, right? So now we have to place the third queen. First, what we will do, we'll check for this one. We can place this one here, right? In the column 0 itself. So we can place the queen here. So we'll just ignore all the other cells for now. This is fine. This is fine. This is the step 3. And let's move on with the next step then. So I have written here, in this case we have placed in the second column, right? So this will be, just give me a second here. Kevin, this is fine. Let's move on with the next step. In this case, what we are doing, we are we have to place the fourth queen in the row 3. Place fourth queen, row 3. So this one is row 3, right? We already have queen here. Yeah, just give me a second here. Queen here as well, and we have queen at the first one. So all other things will just represent this one by dot. So this is fine. Now we have to check for the other things. So here we cannot place, so we cannot have the queen in the same column. We cannot have the queen diagonally as well. So here also we cannot place. So here we can place. We do not have any obstacles here. So we cannot, we can place here. Here also we cannot, because queen, right? We cannot place in the same column. So we can place the queen here, 3, 2 here, right? Second column. So queen. This is for the step 4, right? I hope this is clear. Now we have the solution, right? So this is the solution. This is one solution that we got. This is one solution we got. We can represent this one in this way. So I'll just give me a second here. So here we can write this one in this way. So here this one Q, this is one thing, this is one string, and within the array we have to represent this one, right? This is fine. The second one here is dot 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 q. This is fine. Third one here is q dot dot dot, and the fourth one here is finally dot q dot. So in this way we can represent this one. So the first solution we have found here is this one, right? The step 4. So let's move on with the next step here. So we have already found the solution. Next, again, let's start from the next column. So this one will be this one. We will start from here. We have already started from 0, 1. So we'll start from the second column. This one, let me represent it. Let me represent this one by dot here. We are placing q here and this step. This one in the column 2, right? So this one column 2. We are placing in the column 2. So I'll just give here place queen, right? 0, 2. Right? This is fine. This is for the step 5. So next we have queen here. So we cannot have here, or we cannot have here. We cannot have here as well. So we are placing the queen here itself. Right? We are placing the queen in column 0. So here I'll just give place queen at 1, 0. Here all other things I'll just represent this one empty cells by dot. So I'll just commit next step. Let's go to the 7th step. So here we are placing the third queen. Place third queen here. This case we had queen here, we had queen here. So this will be same thing. So we cannot place here, we cannot place here as well. So here also we cannot place, because you can see here also we cannot place. So we are placing the queen here, third column. So you can just represent this one like this. So this one, let me give dot for the empty cell. Let's move on with the final step. So here in this case, now we have queen here. Yeah, just give me a second here. Queen here, and queen at the final step. So we cannot have queen here and here as well. So we cannot have here as well, right? So we'll be placing the queen here. This is fine. So we are placing it this one, column 1. So this will be queen. So now we have the solution. We can represent the solution in this way within the array. Q dot. So this one Q. This is fine. Sorry. Next one Q. And final one is dot Q dot this one. So this is second solution that we got. First solution we got in step 4, right? This one. So these are the two solutions. Sorry, these are the two solutions that we got here. So you can just visualize in this way. All this one is valid. The fourth one, this one is valid, and the final one is valid, right? So you can just pause the video and have a look into it. So these are the two valid solutions that we got, right? So we can just represent the final output in this way. Just give me a second here. both solution we can write in this way. So this is first solution that we got, right? This is one thing. The second solution that we got is this one. Right, we got these two solutions, which is equivalent to the output that they have shown in the example, first example that I have considered, right? So this approach works absolutely correct in this case. We are going with the backtracking, right? So let's discuss the edge cases one by one very quickly. So the first edge case, I'm going here, we can consider here as for n equals 1. So input n equals 1, output will be here. We can just represent in this way. So n is 1, right? We have to go with 1 into 1 board. So we have only one cell. So the queen must be placed there itself. So this is for the condition n equals 1. So second edge case, we can just consider here for n equals 2 or for n equals 3 here. So the output will be empty. Why the output will be empty are here? So no valid placements exist here because queens will always attack each other. You can just visualize in the same way that I showed for the example 1. You can try it in the same way. Here the output will be empty, right? So let's go with the third edge case for the when n is large. When n is large number. So we can just consider n equals 5, n equals 4, n equals 9, anything. In my case, I'll just consider n equals 4. This is same as example that we have visualized. Same as example 1. Same as example 1 that we saw in the question that they have given. This is when n is large. We saw when n equals 1, second one was for when n equals 2 or n equals 3 condition. So the third one is for the condition when n is large number. The output is same as for the example 1. That's what we saw, right, in the approach. So this is same. So let's next thing is let's write the code. I'll explain the code while writing the code itself. Then finally, let's discuss the complexities of the code that we have written. So let's start writing the code quickly. Here, let's create n into n board that is filled with dot initially. So how can I write this one? I'll just come here. Let me give. Let's consider a result. We have to store the result somewhere, right? I'll just be considering the result and initialize this one to the array. So board. Let me give here, as I've said, let's create the n into n board filled with dot. So this will be array of n. Let's make use of fill here and map all the cells here. Let's make use of map, right? So we are mapping all the cells here. Let me give array of n and individual cell. This is filled with, sorry, what did I do here? Array of n, individual cell. We are filling this one with a dot. And this is fine. I hope this is clear. So this has to be within the strings. This I forgot. So here, this is fine. So the next step is let's consider the backtrack function here. So we are going with backtracking, right? Let's consider the backtrack. I'll just name this one backtrack itself. So let's pass the parameters here. Row, columns, I'll just give here new sec. Then diagonal 1. This is also new sec because we saw this one, right? They have given the rules that one queen means queen can attack in 3 ways. One is either it shouldn't be in the same row. It can attack if it is in the same row, and if the another queen is present in the same column, or diagonal. Either it can be left or right, diagonal, right? So I'm considering set for this. So I'll just go with the another diagonal 2, because left and right diagonal, right? So for that purpose, so again I'll just give here new set. This is fine. So we are just considering here backtrack function, and we have passed the parameters rows, columns, diagonal 1, diagonal 2, right? So the first condition is if all the rows are filled, then we have to add the solution. So how can I write that? This is simple if condition. If r equals n, then return this one, result dot push. So we have to add the solution, right? So what can I write here? Board. Let's map the board here. Board dot map individual row. So row I'll consider here row dot join. This is fine. I hope this is clear. So somewhere did I miss anything? No, right? So this is fine. So what we did here in the last line, if all the rows are filled already, so we have to add the solution. That's what we did. Next, we have to try placing the queen in each column. That's what we saw in the example. That's what I said when I considered the first example and showed every step, right? So we have to try placing the queen in each column, if you remember that. So for that, I'll be making use of for loop. Let me consider this one in the next line. So we have to place try placing the queen in each column, right? That's what we saw. So this one, C less than n. Let's increment the C here. This is fine. We are just trying to place the queen in each column here within the for loop. So we have to skip if the position is attacked. So if position gets attacked, we have to skip that one. That's what we saw in the example. So how can we articulate that one in the form of code? I can just write here column dot hash of C or diagonal. These are the if we can attack, right? That's what I am writing in the if condition. If it should not be present in the column, it gets attacked. The second queen should not be present in the same column, same row, or the diagonal, right? So that one we are articulating in the form of code. So diagonal 1 dot hash of r minus c I'll give here, or diagonal 2 or has. So here r plus c. We are making use of the properties of set here, if you don't know. So if you are not familiar with the set and the properties of the set, I have the JavaScript, this one JavaScript playlist. Please do go through that one. So you'll quickly get to know what I'm writing here. So this one, this is fine. Plus c. Then we will just continue because we have to skip, right? So we are skipping if the position is attacked, right? So that is the reason I'm making use of the this one continue. So next step is we have to place the queen and mark the attacks. Marking the attacks, we are making use of dot to mark the attacks, and we have to place the queen in the safe. We have to place the queen safe. So that's what we saw in the example. So initially, that's what we saw in the approach, right? By considering the example 1. So here, I'll just give here, let's articulate the same thing in the form of code. What we are doing here, we are placing the queen safe and we are marking the attacks. So I can just give in this way. So column, initially, let's consider q, comma, dot add, C here diagonal 1. Again we are making use of add property within the set. This will be r minus c, and diagonal 2. Again add, this will be same, r plus c. This is fine. In this case, again we are placing the queen safe and we are marking the attacks. So next what we have to do, we have to make use of the recursion, or we have to recur for the next row as well. After the first row, we have to go with the second row. In when n equals 4, we did that one same for the second, third and fourth row as well, right? So we have to recur for the next row as well. So here we are making use of the recursion as usual. I'll just copy the function here, backtrack. We have to move to the next row, right? For that one, I'll just give r+1 here. This is fine. The parameters remain same here, columns, diagonal 1, and what are the parameters I've considered? This one, columns diagonal 1 and diagonal 2 here. This one, I'll pass the same thing, diagonal 2. I hope this is clear. We are just using recursion for the next row, or recur for the next row. This is fine. So next what we will do, we have to remove the queen, right? So after this one, we have to remove the queen, or nothing but backtrack to find the other solution. So first solution we find. So all the possible ways we have to find when queens doesn't attack each other. We have to find all the possible ways, right? Here first we have found one solution. Suppose just keep it. Just for the example sake, I'll consider same thing. We have found one solution. Then we have to ignore this one. We have to remove all the queens and start again, right? To if another possible solution is found, we have to add that one as well in the output. So in this step, we are removing the queen, nothing but we are backtracking here. So how can I articulate in the form of code? I'll just give here board of R. See this one, let me give dot initially. We are filling this one again with dot, right? So we are deleting the queens, means we are making use of delete property in the set. What are all the properties that we are using here? The set properties here, we are using add, we are using has, and we are using delete. So again, I'm telling, if you don't know set, please do go through this one playlist, JavaScript playlist, or you can just Google for the properties of set. How can we use it, right? So I'm just we just have to delete the queens here. So I'm making use of delete property in this case. So I'll just give here diagonal 1 dot delete. Two diagonals. Why? Because it left or the right diagonal, right? So here you can clearly see in this way, queen can move in the left diagonal, right diagonal. That is the reason we are making use of two diagonals. So I have explained this one. This will be r row minus column. Finally, diagonal 2, this one we will consider r plus c. So this is form. So this is it for the backtrack function. Let me come out of the backtrack function entirely. So we have to start backtracking from the 0th row, or row 0. Again, we have to start from here, 0, 0, right? Or 0th row. 0th row means first row, right? This one. So just give me a second here. Again, we have found this solution. Now we have deleted all the queens. We have filled everything with dot now. In this case, now we have dot everywhere. So empty cells. Dot means empty cells everywhere. Now again, we have to start from this row, row 0, right? So I'll just make use of here. Just give me a second here. What did I do? Yeah, I'll just give here backtrack. We are starting from the row 0. For that one, I'll just include 0 here. Finally, we need all the possible this one. So we need all the possible solutions where queen doesn't attack each other, right? So here we have two possible solutions. So here we are storing that one in the result. We have considered result variable, right? Let's return the final result here. So I'll just give you a return res. So I hope this is clear. Let me format the code once and let me hit the run button. I hope this works, man. So what this one has? Column is not defined, the line number 8. So just give me a second here. Column I have considered here, calls I have considered here. So yeah, I have considered calls here, right? I'll just make this one add s here. Let me run this one again. Again, what mistake I have done here? Diagonal 2 is not a function. What's wrong here? And the line number 12. Let's check what's wrong here. So yeah, here we are making use of the property delete. So I forgot to use delete here. Oh, this is not a function. This is saying, yeah, this is fine. So let me run this one again. I hope this works now. So yeah, you can clearly see the sample test cases are getting passed here. So let me hit the submit button. So yeah, you can clearly see all the test cases are getting passed here, right? So the solution works absolutely correct. So let's quickly discuss the complexities of the code that we had written. So here the overall time complexity here is big O of n factorial. So why here the overall time complexity here is big O of n factorial? Because for the first row or row 0 we consider for the first row, right? Indexing starts from 0. So we try placing the queen in n positions. For the second row, we'll go with n minus 1 valid positions. One queen is already placed in the 0th row, right? Or the first row. And the next row, we try n minus 1 valid positions. In the second row, next row, we will try n minus 2. In the third row, this is for n equals 4. In the third row or the next row, we will try n minus 3 positions. This will be n into n minus 1 into n minus 2 until into 1, right? So this will be basically n factorial. So this is big of n factorial, the time complexity. So what will be the space complexity here? Overall space complexity here is big O of n to the power of 2 or n square. Why it is n to the power of 2 or n square here? The board takes n square space. The sets take big O of n space. We have made use of the sets, right? So here you can clearly see we have made use of the set. Can clearly see here, right? So the sets take big O of n space. The recursion depth is at most big O of n. We are making use of recursive backtracking. You can clearly see here. Recursion depth is at most big O of n. So board takes big O of n square space and big O of n square dominates big O of n. So the overall space complexity here is big O of n square in this case. So time complexity here we can consider big of n factorial. So I have explained that one as well. So overall time complexity here is big of n factorial and overall space complexity here is big of n square or n to the power of 2. So I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.